All right, today we're going to work in lesson 6.4, and this is focused on inequalities in one triangle. And we're going to look at, obviously, given a single triangle, what kind of inequalities, like when we're talking about angle measures, side lengths, what type of inequalities can we describe within the triangle? And the first one, which is the most important one, is called the triangle inequality theorem. All right, and what this refers to is the side lengths of a triangle. And there's a set pattern that they have to follow in terms of when you look at the sides of a triangle. Any two sides of a triangle always have to add up to be greater than the third side. All right, so if you're just listed and given a list of side lengths, all right, you should be able to identify whether or not those three numbers could represent sides of a triangle just based on this one piece of information called the triangle inequality theorem. And as soon as you can determine that the sum of two of the sides is less than or even equal to the third, then you know those sides can't make up a triangle. So the questions you're going to get are going to be kind of simple to start with, like this. It just says for each set of three lengths, determine if they could be the sides of a triangle. So if you had lengths 24, 6, and 8, could they be the lengths for the sides of a triangle? So really we're asking one simple question. Are the two smaller legs, the two shorter distances given, do they add up to a number bigger than the remaining one? So is 6 plus 8 greater than 24? And the obvious answer there is no. Since 6 plus 8 is not bigger than 24, then these three lengths cannot be the sides of a triangle. All right, how about the next one? Could these three be the lengths for the sides of a triangle? Well, again, I take the shorter two is 4.9 plus 10.1 greater than 14.3. Well, these two add up to 15. That's bigger than 14.3. So could these be the side lengths of a triangle? Yes. This one, again, I just checked the smaller two. Do the smaller two add up to a number bigger than the third? Bigger than the biggest, I guess. So is 8 plus 10 greater than 15? Yes. And then the last set of numbers here, uh, do these fit our triangle inequality theorem? Is 9 plus 17 greater than 29? Are the two shorter legs, do they have a sum bigger than the remaining? And the answer here is no. All right, so one way of doing it is just like this, is to check the two shorter legs and see if you add them together, are they bigger than the largest? That will determine whether or not those sides could even make a triangle. Another way of doing it, and you're going to have these tonight, is to do it using kind of a visual aid here. So they're showing you a side length of 5, 3, and 3. And the question is, could these sides make a triangle? Well, you know by the triangle sum theorem that 3 plus 3 is 6. That's bigger than 5. So yeah, these can make a triangle. What you're going to be able to do is grab these and manipulate these. And if you do that, you could, turn them in, I guess, until they meet at a single point. And it shows here that obviously, yeah, this is a triangle. 3, 3, and 5 could make a triangle that looked like this. Now, coming over here, we got 3, 3, and 7. Well, you know, 3 plus 3 is 6. That does not equal 7. Or excuse me, it's not bigger than 7. So therefore, these cannot make a triangle. And you can see it as you bend the threes down, hinging on the vertex here, they'll never touch each other. So you cannot create a triangle from these side lengths. We knew that using the triangle inequality theorem. We also know it by looking at this manipulative. You're also going to have some that look like this. Okay, and what we get caught up doing is looking at the two that are kind of coming up and saying, all right, yeah, 7 plus 2 is bigger than 4. Well, it's got to be any combination. So it's always the smallest two. Is 2 plus 4 bigger than 7? No. So there's no way that this can be a triangle. If you fold this, if you hinge it and bend it to try to get it to touch, you'll never get these two sides to touch. It can't be a triangle. And the reason it fails the triangle inequality theorem. So you're going to get some questions that deal with that theorem tonight. We also are going to use that theorem. This is a popular question to determine the range of possible answers for a third side of a triangle. So let's say you're given sides 13 and 16 for a triangle. What are the possible range of answers for X? What about this third side? What could it be? And what you need to see here is this isn't it says this figure gives only one possible configuration. All right. This is side X based on the angle right here. As that angle changes, so does the length of x. So our job here is to determine all possible values of x that could help make this a triangle. We're going to write our answers as an inequality, and we can only use x once in our inequality, and I'll show you my answer what they mean by that. All right, so what we do is we start with the idea of the triangle inequality. So what we know is that the sum of any two sides have to be greater than the third. Now, there's three possible inequalities we could write. We could say, all right, I know x plus 13 is got to be greater than 16. I know that x plus 16 has got to be greater than 13. And I know 13 plus 16 has got to be greater than x. That's all three possible combinations for this inequality theorem. Now, take into account this. We know that x is going to represent a distance, a length, so it's got to be positive. And the reason I mention that is because if you look at the middle one here, x plus 16 is greater than 13. This one doesn't help us. 16 is already bigger than 13, so adding x to it doesn't tell us anything. So we really don't need this one. There's always one you're not going to need. All right, so this won't help us, but the two on the end will help us. They'll help determine our solution. So I'm going to look at those two. Okay, I'm going to take x plus 13 greater than 16, and 13 plus 16 is greater than x, and these are the two I'm going to focus on. So if I solve these, okay, subtract 13, I got x is greater than 3. Add these two, I got 29 is greater than x, or you can think of it as x is less than 29. Now I'm going to join these two with the word and you might remember this from back in your days of algebra. And means both conditions have to be true. All right, so any value of x that I want to use up here has got to both be bigger than 3 and less than 29. The way we would write it as a compound inequality, and this is where they say use x only once, the way we would write it is like this. So you start in the middle and say, okay, x is greater than 3 and x is less than 29. Okay, so if you look up here, that's my possible scenarios for x. Now, this is how all of this information comes about, but I'm going to show you a shortcut. Okay, if you look up here, if you take the difference of the two sides you're given, 16 minus 13, that will be the lower end of your values for x. And if you add them together, that'll be the higher end of your value. And then x has got to be between those two numbers. That's the easy way to do this. Okay, so you're given two sides, subtract them, that's your low value, add them, that's your high value, and then your side legs got to be between those two. All right, so if we look at another one of these, very similar drawing, except the numbers are changed. What's the possible range of x values? Okay, I could go through all this with you, and the same things hold true, or you could look at it and say, okay, the low end is going to be 17 minus 9, which is 8. The high end is 9 plus 17, which is 26. I can't equal 8. I can't equal 26, but I have to be a number somewhere in between those two. Okay, and that's our answer. All right, the next concept we deal with is the relationship between side lengths and angle measures. And what this does is allows us to rank the size of side lengths based on angle measures. So there is inequalities involved as we rank them least to greatest, something like that. The key to this, and we've already talked about this before, is that we know in a triangle, the largest side and the largest angle are opposite from each other. Okay, they're across from each other. The largest angle opens up towards the largest side. All right, the middle-sized angle and the middle-sized side, they're opposite one another. And that leaves the smallest side and the smallest angle to be opposite one another. It doesn't matter, what the drawing looks like. We go by the angle measures here. Okay. We also know that if two sides are congruent, then the corresponding angles opposite them are congruent, right? The side lengths and the angle opposites are tied together. All right. So here's how we use that information. They're asking us to rank the order of the three sides of this triangle from least to greatest. Now, they're not asking me the length of the sides. They're just saying which one's the biggest, which one's the smallest. Okay, to do that, we're using the angle measures. Now, you notice I only have two. I got to get the third to be able to do this. So we know angle I is going to be equal to 180 minus 54 plus 40, right? These three got to add up to 180. So 54 plus 40 taken away from 180 is 86. So I know angle I is 86. Now that we know all three angles, we can get the sides. Okay. So we know the largest side is across from the largest angle. So HG is the longest side of this triangle. We know the shortest side is across from the smallest angle. So HI is the shortest side, and we know that the middle side is the angle in between. Now, if you would have looked at this without having this information, you would have thought HG and HI are the same because that's the way they draw it. But notice here, the figure is not necessarily drawn to scale. So you can't do it by what it looks like. You got to have these facts here to use. So the way we'd write the answers, and this is the inequality concept, is we would say side HI is less than IG, which is less than HG, smallest to biggest. All right, so that's using an inequality to rank the sides. Now you could also do this ranking angles. If I gave you side lengths, then the longest side would have the largest angle opposite, and so forth. All right. The last thing we're going to do is we're going to draw some triangles using some manipulative tools over here. And they're going to give us some constraints for the problem, and then we're going to have to come up with a drawing to match it. Okay, so it says use the tools to construct a triangle with angle measures of 15, 15, 150, if possible. If there's no such triangle, click right here at no possible triangle. And remember that it's okay to extend the sides on our triangle, so they don't have to just stop at the vertex. They could go through. Okay, first of all, can you have a 15, 15, 150 triangle? Well, sure. The three angles have to add up to 180. They have to add up right up to 180, and these do. So this is possible. All right, what we're going to do is we're going to start with this utility right here, which is just a straight edge. So I'm going to click on that, bring it down here, then I'm going to click on my pencil, and I'm going to draw a straight line. And this is the line I'm going to build my triangle off of. Okay. The next thing I'm going to do is grab our protractor and set it so that the zero here is right at the end of my protractor. Now these kind of funny. You'll see that it moves around. So you got to click it once and then click it again so it quits moving. All right. Then I won't get the pencil, and I'm going to come up off of this line 15 degrees and put a mark with my pencil. Click right on it. All right. Then I'm going to get my straight edge again, and I'm going to draw a line from my endpoint through my 15-degree mark. And I'm going to extend it through a ways. All right. So I now know that this angle right here is 15 degrees. I'm going to build another 15-degree angle off the other end. Okay, so I'm going to put the center here, and I'm going to click it a second time so it quits moving. You'll see what I'm talking about when you do it. I'm going to click on a pencil. I'm going to come up 15 degrees, put my another X right here. I'm going to then connect the endpoint to that new mark, and I will have a triangle that's got a 15-degree angle here, 15-degree angle here. This obviously then has to be 150. It has to be. I don't even have to measure it. It's got to be 150. Okay, so that is one possible way we could do it. Okay, a second way we could do it would be this way. They would say, okay, same kind of deal. You're going to create a triangle, but this time we want the side lengths of 3 and 6, and I want 160-degree angle between these two. Okay, so this is a little different set of instructions, right? So what we're going to do is, the first thing I'm going to do is draw a 3-inch line that's going to be the first side of my triangle. Okay, so there's 3 inches. Now off of this line, I'm going to make a 160-degree angle. So I'm going to put the center here, and this got kind of twisted on me, but if you notice, see how this line goes right through 160? So then I marked right on this edge here. So I know that this is 160 degrees. Here to here is 160. Okay. Then I'm going to take my ruler out again, and now I'm going to go from this point up 6 inches because I want a 3 and a 6 to be the side lengths here. Once I do that, then I just have to connect the two endpoints, and I get this triangle. Okay. This is 3. This side is 6. That angle's 160. All right. So you're going to play around with some of those tonight. So that's the work on inequalities in a triangle. Okay. You'll see the same exact type of questions tonight on homework. There's not a ton of work to show, but there's a little bit you can write down as you go. All right. I'll let you have at it.